Hi everyone, my name is Roger Lapuh. Today I'd like to talk to you about scaling your Fabric Connect network with an SPB ISIS multi-area solution. This solution is part of our infinite enterprise architecture and really enables an effortless experience for our customers. So the solution that we are bringing out here allows us to enable an end-to-end fabric, basically tying together branches, campus, core, edge networks, data centers, metro area networks in a one unified end-to-end fabric to very large scales. So for now with this multi-area solution, you can go beyond the limits that we had previously with 500-600 nodes in a fabric, 2,000 nodes in a fabric. So let's dive into details of the fabric multi-area solution. So what are the reasons to deploy besides scaling the nodes of the fabric? The reasons for that are, for example, route summarization. So you can summarize routes between areas. So you can not only scale your nodes in your SPB fabric, but you can also scale your IP routes in your fabric. So that's another scaling reason to do. An additional reason to do multi-area in your infrastructure is to separate services off from other areas, basically do a secure service zoning, where you could say my data center has certain services, certain ISITs, and I assume you guys listening know what SPB is and what ISITs are. So I'm going to use that ISIT acronym. So you can use service zoning with multi-area to restrict, for example, data ISITs off from, say, campus ISITs or WAN ISITs or WAN networks. So you have a good way to secure services off. I'm going to talk about that in more details later. And then there is obviously an additional reason for creating multiple areas, a multi-area solution with multiple areas. It allows you to interconnect smaller IGP domains to reduce maybe possible CPU loads in your smaller devices. If you, for example, have a very busy multicast network, you can segment your network off into smaller domains and then do multi-area between them. So these are the reasons for you to possibly deploy multi-area solution. So let's go and look at this more detail and start with the overview. How do we do this? How do we provide this? So with release 8.4 of VSP, we're introducing this capability. And the key thing that you need to know is that the VSP 7400 platforms, the Y version, the C version, which are the 25 gig version and the 100 gig version, those are the two nodes that enable multi-area capability. All the other nodes can participate in a network with multi-area, but they don't enable that boundary functionality. So those two pinkish nodes here are the boundary nodes, multi-area boundary nodes in this infrastructure, and all the other nodes are the existing nodes. The key thing to know also is that the existing nodes or the non-boundary nodes, they don't need to be upgraded or anything like that. They don't need to know about multi-area. They can just participate. So that's a key element of the multi-area solution. Another key element of the solution is that we connect two areas with each other with a boundary node or a couple of boundary nodes if you have a redundant solution. So two areas interconnected. And I will show you how you can build very large scale deployments, but basically boundary nodes connect the so-called home area, which is here the area 49C1, where the nodes are sitting in, and the so-called remote area, which are illustrated through the yellow lines, 49DC1 area. So you see those pinkish nodes have these two different connections. So the links define which area they belong to. So the link, basically these links are part of the remote area because we're connecting from the home area, which is over here, to the remote area over these green links. So these are the two concepts you need to know. Home area links and remote area links. And the green one basically allows us to connect the switches with home area links and remote area connectivity. Therefore, you close the loop here, the ring here, and you close the ring here. So you have a redundant connectivity for home and remote. So home and remote is a construct that you need to know of in a multi-area deployment, but it's really just ties related to a box, the boundary box itself. It's not a construct that is exchanged with any other switch. It's just a local nomenclature, and defines, the home area defines the area where this box has its UNI and IP interfaces in. So something to get used to, and that's why I want to make sure I spend enough time on this to explain the home area and the remote area construct. And I'm going to repeat in the upcoming slides these colors and dots and so on are repeated. Now, what do we support in terms of between area communication? So the redistribution support, basically you can redistribute between the areas, layer 2 services, E-trees, layer IP, global routing table IP routes, layer 3 VSNs. We can extend bridged or router multicast. We can extend the DVR backbone. We can extend IC mirroring. We can extend IPv4, IPv6. So basically the whole 9 yards. So you can redistribute between the areas basically any of the capabilities we support of the switches. There is a small amount of not supported redistribution, but it's very, very small. Now, how is this redistribution functioning and operating? So you can imagine here, you see the box, the purple box here is your switch, and it has NNI links. These are the red links in the home area. So for this box, these links are the NNIs in the home area, and the UNI links here in the home area. So again, the home area is defined where the UNI interfaces lie and where the IP interfaces lie. So this 49DC1 area is redistributed to through the redistribution functions, and those are remote links. Now, okay, here is basically CLI commands. And I'm not going to go through the CLI commands, but I'm basically showing how you redistribute. How do you decide how to redistribute between the areas? So you can select, I want to redistribute my layer 2 services, basically your 2 ISIDs, all of them, or just a subset of them. You can define your layer 3 VSNs, what you want to redistribute from and to your area. You can then also deploy route maps to basically restrict subnets, and also you can be very restrictive in what you want to redistribute. So it's very granular, very flexible, and because we wanted to achieve a very secure zoning capability, so you can use this feature also to secure segment of your zones and your routes and ISIDs, obviously, and VRFs and so on for between the areas. We support layer 3 multicast redistribution between the areas. You can go down granularly to the multicast stream and say which ones you want to redistribute between the areas and which ones not, or you can just globally say, I'm going to redistribute everything, all multicast between the areas for this particular VRF. So you can do per VRF redistribution if you want. And similarly, you can also do DVR redistribution. So the point here is, it's very powerful capability, providing very powerful capability for redistributing and securing, defining secure zones of your infrastructure. Now, here are a few things that are good to know when we talk about multi-area. First of all, the multi-area, here you see a green and a bluish area. The area that you're connecting to with these 2 boundary nodes is represented by a virtual node. These 2 boundary nodes here define or create a virtual node that is now, when you do this, is popping up in this area here. So this virtual node VG needs to be counted as 1 node. Basically, you add a new area, then that new area is added as counted as 1 additional node in your, for example, blue area here, and an additional node in your green area here. So node count goes up by 1 virtual node, plus obviously the boundary nodes. If they are new as well, then you would have 3 additional nodes in your area. So don't go beyond 500 in each area, but you can obviously do many areas. You can chain them. Don't chain more than 5, we're saying here, but you can chain areas. And I'll have more examples on how this is done. And down here is also what you shouldn't do. You shouldn't create area loops. So if there is an area loop created, then the boundary nodes will shut down themselves and the loop is broken up. So it's not a design that we support, but if it would occur, somebody would configure this erroneously, then we would disable the boundary node function on that switch so that we don't have a potential layer 2 loop, for example. If a layer 2 VSN is appearing everywhere, we basically ensure that multicast and broadcast loops are not happening between areas this way. But again, still, this is illustrated here with one node, but obviously still you can have redundant nodes everywhere here. So we will see examples for this. Now here, let's go into the more detailed constructs for your multi-area design. So here you have this, say, campus area with the boundary nodes here, which have these two in the home area, 49C1, and then a connection to the remote data center here as a remote connection to 49DC1 area. So this would be just physical links connected and remote configuration running on this. But you can also have a different construct. You could say, okay, I'm going to make these two guys also boundary nodes and these two boundary nodes. And keep in mind, VSP 7400 switches, they support that multi-area boundary function, and here as well. And then you can interconnect those boundary nodes with a so-called backbone transit area. So you will see how this comes in very handy in future upcoming slides. And these can be physical links as shown here, or they can be fabric extend links dashed here, fabric extend dashed connections over IP. So this could be your IP MPLS infrastructure, and you interconnect these two areas over that transit area. And again, the area only exists on the links. It doesn't exist anywhere else. Okay, so let's take this further. So let's say you want to add a new area to your infrastructure. You have 49,000 as your area, and you say, okay, I'd like to introduce this backbone area. How do I do this? So maybe in your data center you have a couple of ESP 7400s. You turn them into boundary nodes, and then bring up this new building here with a couple of boundary nodes here, and maybe VSP Edge running in this infrastructure. So fabric to the edge, everything is in 4901, it's 490C1, or this can also be fabric attached. It doesn't have to be fabric connect to the edge. It can also be Exos Edge with fabric attach MLAG connectivity to a pair of VIST switches here running boundary functions. So both is supported. But again, here showing how a backbone is introduced into your infrastructure. And this introduction of a backbone area is basically showing how you can expand your infrastructure to a multi-area solution. So the next slide here is showing 3 examples of how this backbone transit area could be created. So you could do a kind of a mesh solution like this. And keep in mind, we say we support right now 2 switches per area as boundary nodes. So that's why it's illustrated to 2. The technology itself could go more than 2, but we are right now just tested with 2. So two nodes are the boundary nodes and interconnect with the rest of the infrastructure. So that's an example. You can also do a high-speed ring. Let's say you do everything 100 gig. You could have a 100 gig ring here connecting this, or you could put in additional switches that don't need to be 4700, 7400. It can be something else into the backbone area and just interconnect, make them the backbone area switches interconnecting those boundary nodes here. So these are examples of backbone and introduction of a backbone area make it a very scalable infrastructure. And as I previously have shown, these links here, they will be part of the home area as well as the backbone area. So they will be running basically both ISIS adjacencies on the links. And here another one is a good one here is if someone would take a link configured with 49C1 area and tries to connect it to the 49C2 area, this link wouldn't come up, right? Because the adjacency, different ISIS areas, the adjacency would stay down, wouldn't come up, so no loop, nothing would be created. It just basically ensures that there is no problem happening here if somebody interconnects this way. If you configure the backbone area 49BB on here, then obviously the link would come up. So it's a good way to show how multi-area can can provide a very nice, very scalable solution. So let's go from here and look at how can I migrate from a traditional network to a multi-area infrastructure. And this is with an example where I have an aggregation layer, fabric enabled, and then I have, for example, ERS or ERS edge switches connected with stacking switches connected with an MLT down to a VIST pair, virtualized T pair with SMLT links to a couple of switches. Now, how do we introduce a multi-area construct here at the same time migrates, for example, these ERS edge switches to VSP fabric edge? How would that look like? So I can introduce a new pair of boundary nodes. So this would be a pair of new switches, 7400s, which are collocated with this pair here. There, that's why this dotted line. So basically this illustrates the collocation between the switches in this building. Basically they're now in the same building, but we want to bring them to the new area C1 from the original 4900 area. So I can connect these switches, connect them with remote area connectivity to these two. I can have these links here or not. These links can be optional. I can just bring those cables over, connect it to these guys, and close the fabric like that, the 4900 area like this, or I can keep them, doesn't matter. Now I'm going to introduce, so to make them boundary nodes, I'm going to introduce now an edge switch here that I want these devices being, or these, not devices, but end stations being moved over to this guy. So maybe take this ERS away and make this a VSP edge, and then make these VSPs, because this could be a very large building where I have more than, where they have a lot of switches. I want to make this its own area. I can just bring them on, make sure they're part of this. I mean, by making this the home area, I can make them part of this home area 49001, use zero touch fabric and make them become part of this new area. And now I'm starting to break up or dismantle this this old ERS configuration and basically build a new separated fabric for my building here. And then I can also dismantle the aggregation layer switches. So I'm basically everything moved over. So you can step by step, closet by closet, move everything over. And at the end, I can dismantle the aggregation layer switches. And at the same time, I have now introduced a multi-area construct. So this is showing an MLAG. Black lines means MLAG here, an MLAG ERS building, ERS being the Ethernet routing switches from Extreme, migrating them to a fabric edge solution with multi-area. Now the ERSs also support the fabric edge. So this would be depicted here. So the ERSs would be running fabric edge. I can do the same approach here, slowly taking the ERSs out of commission, decommission those, and then bring in the VSPs similarly as before. So basically the same way, migrating to a multi-area construct, new building deployment. So there is quite a few customers that are thinking to go along these lines and do that kind of a migration strategy. So that's why we illustrate here how this could be step by step done without any intrusive configuration changes. Let me talk quickly about layer 3, right? You can keep layer 3 running. Let's say this building layer was running your layer 3 routing. You can keep that layer 3 routing until you have everything migrated over and then migrate it to the new guys, right? Or you can migrate layer 3 first and then migrate the closets. It doesn't matter, right? We can, in this case, it does not matter. In the previous case, where we had SMLT attached closets, it probably is better to keep layer 3 here until you migrated everything over and then migrate your layer 3 to your new switches. But you can, obviously everything will work seamlessly here as well. So step-by-step migration without intrusive hard cut over requirements. You can definitely do a hard cut over, but you don't have to. That's basically the message here, how to introduce a multi-area solution. Now, you can take this obviously a step further and build a very large deployment where you have multiple buildings connected with a backbone area construct here, and interconnect them through this backbone area. Just an example here of making this construct larger than just shown before, right? So this can be done this way in this solution, but you could also introduce, and nope, it's not here. You could also introduce a pair of backbone switches aggregating the links of all those areas as the core nodes being in the backbone area, and then interconnecting those other buildings to those core nodes. So there's multiple ways to skin the cat. Here is an example where we don't have core nodes depicted. So this is pretty large, which shows a data center area with 2 data centers, one on the left, one on the right. It's also showing a WAN infrastructure where you might have your XAs connected over the internet with terminated on 7400s being the IPsec termination points. Also multi-area in its own area. So it's always a good idea to separate off your WAN area from your campus areas. It's always a good idea to separate your data center into its own area. You don't have to, but it's always a good idea, because this one would allow you to control with redistribution, control which services go where. So yes, so this is a good size network, but if you can go even larger by chaining up to 5 areas. So this would be 1, 2, 3, 4, 5 areas chained. So this is, as far as we do say, go very large deployments. So you have 4 metro areas. You obviously can go to many more than 4 metro areas, but this is depicting 4 metro areas that are interconnected with a WAN backbone area. This WAN backbone area could be an MPLS IP VPN area that we're using with Fabric Extend, connecting those metro areas with each other. So you see this area multi-area construct is a very, very scalable solution. And I have not mentioned it in the beginning, but I'm going to mention it now. As you can see, our multi-area construct is not using ISIS level 1, level 2. We are actually using 2 equal areas, basically level 1 areas, and we're interconnecting level 1 areas with a redistribution function. So there's no level 1, level 2 construct. The backbone area is not something special. It's just an area we did not basically call backbone area, but there is no such thing in ISIS. So for our infrastructure. So basically we have 2 areas configured on our switches, and this is how you use that home area, remote area, 2 area construct to then scale to very, very large solutions. So if you have deployments that you want to grow to multi-area, to very large deployments, please involve us, involve your contact, your system engineer, involve professional services if you need help. They will reach out to engineering and PLM to really support this. We have a lot of interest around multi-area, and we will be seeing I think a great adoption of this technology, and really allows us to build very, very large deployments. This one last slide basically collects the multi-area as well as the VSP Edge components together in one slide. So this is more as a reference, but you see here the campus areas with a multi-area boundary node switches here in the campus aggregation layer, 2 campuses, 1 and 2. Connected through a backbone area, transit area here, which is basically just configured on the links, not anywhere else. Then you have the data center. One example here is 1 data center with also boundary nodes connecting to the backbone transit area. Then you see here your management infrastructure, which can be on-prem, and also there's obviously also ability for cloud-based internet connectivity for XIQ-based capabilities. Now, what you also see here is what is running on those nodes. For example, these boundary nodes are running boundary node functionality, but they're also, for example, running DVR controller functionality with the DVR leaf capabilities. Then they would be running nickname server. Nickname server is the capability for zero-touch deployment. So if you want to deploy all these switches without having to configure anything on your switches here, you can deploy them as zero-touch in the campus or in the data center. And the nickname server is there to provide the nicknames. It's like a DHCP server, provides the nicknames to the switches so that they have unique nicknames provisioned in the fabric. So you would run your nickname server in the home area here, for example. So basically, this is just, as I said, an overview slide of all where the capabilities would be running. Now, so what is a global network service? What is a per area network service? Summarizing, basically, you would have your management as a global service. XMC, XIQ side engine would be a global service. You would have Radius as a global service. Typically, you would have your DHCP server as a global service. You would be running this DVR backbone, this distributed virtual routing, as a global service. So because it would be extended so that you can have roaming between areas. If you want to roam your wireless clients, or you want to roam your servers between multiple areas, you can extend the DVR backbone between areas, make it a global service. You should make sure you configure your ISITs or define your ISITs as a global ISIT structure that will allow you easily to make sure that you can extend services between areas. So look at this as an ISIT range as a global construct, and obviously then use redistribution filtering to ensure which ISITs you want to keep local and which ones you want to extend. And then again, per area, you would be using the nickname server per area as the zero-touch deployment capability per area, and you would use your DVR controller functionality for your DVR leaves in that area as being a per area functionality. So this should give you an overview of how to deploy how we want to have our new deployments and basically fully sophisticated fabric to the edge networks deployed. What are the components? What are the different elements? Obviously, there will be a lot of migrations, which will go step by step, which won't use all these capabilities day one. So this, a mix and a slow growth into this is absolutely also possible. So you don't have to go full blown into this, but this, as I hopefully have been able to show you, this multi-area capability is going to give you a lot of power to really grow your infrastructure and keep it end-to-end automated, right? The whole goal why we want to do an end-to-end multi-area solution is to do end-to-end automation, to really simplify your life, simplify deployment, and bring the capability that we had in the single area now to very, very large deployments. Okay, so with that, thanks a lot for listening, and please reach out if you have more questions. Thanks a lot.